How is the sound now? Can everybody... All right. It's working now. Great. Apologies for that. All right. As I was trying to say before when you couldn't hear me, welcome to another astronomy trivia night. As a lot of you have already figured out, all you have to do is to put in your preferred username into the kahoot.it webpage or the Kahoot app if you prefer that, and enter the game pin 7667656. Do remember that this is a family-friendly show, so when you're putting in your name, try to put something family-friendly, just to keep it nice, and we'll get started just as soon as we have a few more people joined in. So thank you all for joining me once again, and we'll get started in a moment. And while we're waiting, I should probably introduce myself. So whoever has played trivia nights before, you might recognize me. My name is Dr. Ilana McDonald. I work at the Department for Astronomy and Astrophysics at the University of Toronto. And yeah, I did my PhD in astrophysics here and studied the ripples in space-time that come from black holes that are spiraling around each other, which is pretty fun. So let's just wait for a couple more people to enter. Remember to put in your email address if you do want to win a prize. We do promise not to contact you unless you've won a prize. But if you don't put in your real email address, obviously we can't contact you. It's great to see so many of you here today. We've already got 77 people on the stream who are playing tonight, which is really, really great. And one last time before we get started, if you're just joining us now, please go to kahoot.it and put in the game pin 7667656, which you see at the top of the screen. And we will get started with the game. All right, so let's give it a go. Let's get started here. 85 participants, that's amazing. I think that's the most we've had in a little while. So, of course, this game is powered by Kahoot, and our theme for the night is Cosmic Origins. So we'll get started with the rules to begin. So anyone here is allowed to play. However, we can only send prizes to people within Canada, except for Quebec. So I'm sorry, Quebec, and I'm sorry, anybody outside of Canada. But if you are in those places, you can still play along in order to, have a bit of fun and learn a little bit about astronomy, but you can't win a prize. People who have graduate degrees in astronomy or some equivalent expertise, unfortunately, you also cannot win any prizes. It's just unfair for those who don't have a PhD in astronomy. Also, if you are a person under 18 years old, please get your parents' permission to play. And because there may be people who are younger who are playing, please keep the chat respectful and family friendly. And as I already said during the introduction, if you want to win a prize, you have to use your real email address in Kahoot, and we promise we won't use it for any reason except for to contact the winners. So, here are the prizes you can win, the moment everyone's been waiting for. So how it works is there will be 3 prize winners. The first prize we have is this heat-changing constellation mug. So if you're the first prize winner, you get to choose whichever prize you want. If you're the second prize winner, you get the choice of whatever's 2 are left over, and so on and so forth. The next prize we have is this 3D printed moon globe, which I can assure you is super, super, super cool. Changes color and everything. And then the third one is this super cozy constellation throw blanket, which is very necessary, I think, for weather like we've had today in Toronto. It was about -20 all day, and it was very, very cold. So a cozy throw blanket with constellations on it is just what the doctor ordered. And before I forget, and before we get started on the questions, I just wanted to do a brief land acknowledgement, since we are on the land of various Indigenous people. So I just want to say that we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it's been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this is the meeting place, is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. Okay, so now we are ready for our questions. This one is a little bit tricky. It's what we call a multi-select question. So what evidence do we have that the universe began? That is, that it hasn't just always been here. So select all of the answers that apply. They are: the universe is expanding, the existence of the cosmic microwave background, the existence of black holes, and the current mixture of elements in the universe. What evidence do we have that the universe began? So you can select as many of these as possible, as you think are correct. And if you selected the universe is expanding, the existence of the cosmic microwave background, and the current mixture of elements in the universe, then you got the correct answer. So that was a little bit tricky because you had to select a lot of different things. But the existence of black holes is not a piece of evidence that shows that the universe began, and not that it didn't just always exist. So let's see how you've all done after the first questions. It looks like Maelstrom 127 is in the lead right now, with not Ryan in a close second place. Let's go on to the next question and see how you do. So here's another one. How old is the universe? Is it 13.8 billion years old? Is it 42 billion years old? Is it 2.5 million years old? Or is it only 6,000 years old? So how old is the universe? So for each of these questions, you have about 30 seconds to answer. So make sure that you get those answers in quickly, because the faster you answer, the more likely you are to get more points, which puts you at the top of the scoreboard. All right, time's up. And we seem to have frozen a little bit here. That's okay. There we go. Most of you got the correct answer, and that is 13.8 billion years old. So we believe that 13.8 billion years ago, the universe started, as far as we know, and that is when the Big Bang happened. Moving on to the scoreboard once again, Maelstrom 127 has maintained their lead. Excellent job. So let's see if everyone else can catch up in this next question, which is, in the hit TV show, The Big Bang Theory, who wrote the theme song that describes the history of the universe? A surprisingly accurate theme song. So was it U2? Was it the Bare Naked Ladies? Was it the Tragically Hip? Or was it the Arrogant Worms? So which of these bands wrote the theme song for the show The Big Bang Theory? Got about 5 seconds left. Get those answers in. And it looks like most of you got the correct answer, which was the Bare Naked Ladies. Very, very good. Yes, the Bare Naked Ladies wrote the theme song which goes, the whole universe was in a hot, dense state. Then 14 billion years ago, it started expansion started to wait. Is that how it goes? Anyway, it's a fun show and has a good theme song, which is my favorite part about it. So looking at the scoreboard once again, Maelstrom 127 is in the lead, but it looks like a few people are starting to catch up. So for this next question, it's a true or false question. Using very, very powerful telescopes, it's possible to see light from the Big Bang itself. Is this a true or a false statement? So using very powerful telescopes, we can actually see light from the Big Bang itself. Is this a true statement or a false statement? So get those answers in. Remember, the faster you answer, the more points you can score. And your time is up. And most of you answered false, which is true. We can't actually see light from the very, very beginning of the universe. We can only see light that occurred a little bit later. So, looking once again at our scoreboard, and I didn't want to say more about that because there might be some spoilers for later questions, but we still got Maelstrom 127 in the lead, and a few people catching up. That's great to see. All right, one more question about the early universe. How old was the universe when the earliest light that we can see was emitted? So we can't see the light from the very, very beginning of the universe, but how old is the oldest light that we can see? Is it less than a second? Is it 11 minutes? Is it 370 years? Or is it 1 million years? How old is that earliest light that we can see? Or how old was the universe when that earliest light was emitted, I should say? And most of you, once again, got the correct answer. Excellent job. So the universe was about 370,000 years old when the earliest light that we can see was emitted, which we call the cosmic microwave background. And this light, so anything that happened before this time, we aren't actually able to observe, though the light that is emitted from this very early state of the universe gives us a lot of clues of what it would have been like before that light was emitted. Looking once again at our scoreboard, Maelstrom 127 is still maintaining that lead. Excellent job, but Cosmic Chances has snuck into second place. So let's see how the rest of you do with this next question. How hot was the universe when this cosmic microwave background was emitted? So was it about the same as the core of a star, about the same as the surface of a star, about the same as the inside of an oven, or very close to absolute zero? So how hot was the universe when this microwave background was emitted? So about the same as the core of a star, about the same as the surface of a star, about the same as the inside of an oven, or very close to absolute zero. And the correct answer is actually about the same as the surface of a star. So many of you answered about the same as the core of a star, which is millions of degrees, whereas the universe was only about a few thousand degrees in temperature when this cosmic microwave background was emitted. And this was the point when the universe was just cool enough that all of the atoms that were buzzing around were able to recombine with their electrons, and a whole bunch of light was all emitted all at once. Because before this point, the universe was so hot that all of the atoms were, all of these electrons were floating around, and light just couldn't travel very far in any one direction. So as the universe expanded and cooled, all of this light was emitted all at once. So, Scoreboard once again, we've got Maelstrom 127 still in the lead and Cosmic Chances maintaining that second place. Let's see if the rest of you can catch up with this next question, which is, what do we call the period of time after the cosmic microwave background was emitted, but before the first stars appeared? So was it called reionization? Was it called primordial nucleosynthesis? Was it called the photon epoch? Or was it called the Dark Ages? So what do we call that period of time after the cosmic microwave background was emitted, but before the first stars appeared? And the correct answer is the Dark Ages, which is a less fancy sounding name than these other names, but it is an accurate name because during this period of time, you didn't have a lot of light that was being emitted, and the first stars hadn't formed, so the universe wasn't very bright, so we call it the Dark Ages. And all the universe was doing at this time was it was mostly just this gas that was cooling down and slowly coalescing into what would become the first stars. Now, looking at our scoreboard, something very exciting has happened in that Cosmic Chances has moved into first place. So congratulations to you. Let's see how it develops over the next few questions. So our next question is, in which Marvel TV series is a strange broadcast discovered within the cosmic microwave background? Is it Agents of S.H.I.E.L.D.? Is it WandaVision? Is it Agent Carter? Or is it Loki? Which one of these Marvel TV series has a strange broadcast that's discovered within the cosmic microwave background? Three more seconds to go. 2, 1. Time is up. And you guys are up and up on your pop culture references because most of you got the correct answer, which is WandaVision. So there was a mysterious television broadcast that was discovered within the cosmic microwave background in this very fun show. Looking at the scoreboard again, it's a fight to the finish between Maelstrom 127, who has snuck back into first place, and Cosmic Chances, who's now moved into second. Moving on to another true or false question. The first stars are thought to have been large, bright, and short-lived, yet we've never detected one. Is this a true statement or a false statement? That the first stars were large, bright, and short-lived, but we've never detected one. Is this true or is this false? Time is up, and most of you got the correct answer once again. That was a little bit tight. It is in fact a true statement. We have not yet detected the very first stars that we think formed. However, we do believe that they must have been very large, very bright, and very short-lived, and probably formed some of the first elements. Looking once again at our scoreboard, we've got Maelstrom still in the lead with Cosmic Chances in second, Professor Laser having moved up to third place. Excellent. Our next question is, how old was the universe when the oldest known galaxy formed? So was this 600,000 years old, 12 million years old, 400 million years old, or a billion years old? So how old was the universe when the oldest known galaxy formed? So you've got about 8 seconds left. Get those answers in. So it was a pretty even spread over all of those answers, but it seemed like the majority got this question correct. And it is 400 million years old. And in fact, this is a galaxy that was detected by the Hubble Space Telescope that is called GN-Z11. And it is, as far as we know, the oldest known galaxy and the farthest galaxy that we've ever been able to observe in the universe. And formed, we think, or we're observing it, when the universe was only 400 million years old, which sounds old, but of course in the grand scheme of the entire age of the universe is not very old at all. All right, looking once again at our scoreboard, it's almost the same, but it looks like Leaf in the Wind has moved up to 4th place. Interesting development. Let's move on to the next question, which is, which famous astronomer is usually credited with the discovery that the universe is expanding? So was it Albert Einstein? Was it Isaac Newton? Was it Edwin Hubble? Or was it Henrietta Swan Leavitt? So which of these astronomers / physicists is credited with the discovery that the universe is expanding? So we've got about 5 seconds left to get those answers in. And most of you got the correct answer. Excellent job. It was indeed Edwin Hubble who is credited with the discovery that the universe is expanding. And so his discovery was in 1927. He noticed when he was looking at distant galaxies that the farther away a galaxy is from us, the faster it's moving away from us. And so this implied that the universe is in fact expanding, though there are some arguments as to whether or not he came up with the idea that the universe is expanding and didn't just make this discovery of this relationship between the distance of these galaxies and how fast they were moving away from us. So let's move on to the scoreboard, which hasn't changed at all. So let's move on to the next question. What have observations of the early universe taught us about its fate? So what have observations of how the universe started taught us about how it might end? And so has it taught us that it will continue to expand faster and faster? It will continue to expand forever, but more and more slowly. It will expand to a point and then start to contract. So which one of these have observations about the early universe taught us? And once again, many of you got the correct answer, which is that it will continue to expand faster and faster. And so we've observed that farther and farther galaxies from us are actually moving away at a rate that is slower than expected, which means that galaxies are moving farther and farther apart from each other now, faster than they were in the past, which means that the universe is accelerating in its expansion. And this is due to something we like to call dark energy, but we don't actually know what it consists of. So this is just an explanation as to why the universe is accelerating in its expansion, which we've observed, and we still are looking for an explanation. Looking once again at the scoreboard, it has changed a little bit in that Leaf in the Wind is now in 3rd place, and Space Girl has moved on to this, the scoreboard. Excellent job. Our next question is, what 2 elements were created in the very early stages of the universe's formation? So what 2 elements? Was it hydrogen and helium? Was it oxygen and lithium? Was it carbon and nitrogen? Or was it silicon and iron? So which of these elements were created in the very early stages of the universe? You've got about 5 seconds left. 3, 2, 1. And almost all of you got the correct answer. Excellent job. The answer is indeed hydrogen and helium, which are the 2 lightest and simplest of the elements. So we think that in the very, very early universe, we started off with hydrogen. There was a brief period of time where helium was forming, and then all the other elements that are heavier than this had to be created in the cores of stars, which of course we know didn't form until much later. Looking once again at our scoreboard, it's exactly the same as it was before, but let's see if some more of you can catch up to beat our current leaders. Our next question is, How old was the universe when the first elements heavier than hydrogen formed? So we learned in the last question that helium formed in the very early universe. How long did it take for that to form in the very early universe? Was it a few nanoseconds? Was it a few microseconds? Was it a few seconds, or was it within a few minutes of the beginning of the universe? So you've got about 2 seconds left, 1 second, and it looks like more people than not got the answer, so that's excellent. It was within the first few minutes. So most of the helium that we see in the universe was actually formed within the first roughly 20 minutes, with trace amounts of lithium and beryllium in the very, very early universe. And any helium that was created after that, any heavier elements than that, were all created later when the first stars formed. All right, looking once again at our scoreboard, it's just about the same. So let's move on to our next question. What cosmic event needed to take place for the first planets to form? Was it the first galaxies forming? It was the first generation of stars exploding? Was it disks around the first black holes forming? Or was it stars forming in clusters? So which of these things did you need? And most of you got the right answer, which is the first generation of stars needed to explode. So these first generations of stars had to have been made of mostly hydrogen and helium. These very large, very short-lived stars, and within their cores, they fused that helium and hydrogen together to become even heavier elements. And those elements were what was needed to create the buildup to have your first rocky planets that had carbon and oxygen and silicon and all that fun stuff in them. So you really needed to have those first generations of stars died for the next generation, or for the next generation of stars to form, and then for the first planets to form. So let's look again at that scoreboard. It looks like Professor Laser has moved into third place. Excellent job. Moving on, so many of you might recognize this image because it's made the news in the last few days, that's for sure, the last few weeks. This is an image of the James Webb Space Telescope, which was just fully successfully deployed within the last few days. Everyone is very, 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 very excited about it. And so since one of its goals is to learn a lot about the very early universe, which is our theme for today, I thought I'd put in a few questions about this brand new telescope that's going to be coming online within the next few months. So let's move on to those questions. So, how far into the past will James Webb Space Telescope be able to gaze? So is it 100 million years? Is it 3 billion years? Is it 13 billion years? Or is it 20 billion years? So how far into the past will the James Webb Space Telescope be able to look? 100 million years, 3 billion years, 13 billion years, or 20 billion years? Get those answers in. Yes. All right. It seems that more than half of you got the correct answer, which is 13 billion years, if not a little bit more. So what James Webb is hoping to be able to see is the very first stars that ever formed, the very first galaxies that ever formed, and those would have been just in that period of time after the Dark Ages, which is pretty cool. We're all very excited to be able to see those first images. Looking once again at our scoreboard, it appears that things are about where they stood last time. So let's move on to our last couple of questions. So what kind of light is the James Webb Space Telescope optimized to detect so that it can view those galaxies from the beginning of the universe? Is it ultraviolet? Is it infrared? Is it radio? Or is it visible light? So what kind of light will the James Webb Space Telescope be able to detect most precisely to view those galaxies from the beginning of the universe? So is it just about run out of time? There we go. Most of you got the correct answer once again, on point tonight. It is indeed infrared light. So the James Webb Space Telescope, unlike its predecessor, the Hubble Space Telescope, which is optimized to see visible light, James Webb is optimized to see infrared light. And the reason for this is that as the universe is expanding, all of that light, which might have been in the visible range in the early universe, has expanded and stretched to increase its wavelength to move into the infrared range of light. And so that is why the James Webb Space Telescope is optimized to see those wavelengths, to be able to view those very, very early galaxies. Once again, our scoreboard has remained unchanged, but I'd like to congratulate Space Girl for getting 10 correct answers in a row. That's quite an accomplishment. This is our last question of the night. What type of object will the James Webb Space Telescope not be observing? Is it objects in our solar system? Is it extrasolar planets, that is, planets going around other stars? Is it star formation regions? Or it will be observing all of these. So which one of these objects will the James Webb Space Telescope not be observing? So get those answers in as fast as you can. And most of you, once again, got the correct answer. The James Webb Space Telescope will in fact be observing all of these types of objects, including objects in our solar system. So the hope is that we'll be able to get some really neat close-up views of the other planets in our solar system using this telescope, as well as stuff that is far outside of our solar system, far outside of our galaxy, and of course looking at things from the very early galaxy itself. All right, before we move on to our grand prize winner and see who our top 3 prize winners are, I wanted to plug another event that's coming up in just 2 days, which is an Astro Tours, which is organized by the graduate students in the astronomy department at the University of Toronto. And the title is Cosmology with Galaxy Clusters, so fairly relevant to the stuff we discussed today. So there will be a live stream on YouTube this Thursday, January 13th at 8 p.m. There will be a description in the in this video's description with a link, so you can go there. And there's also going to be online demos afterwards, and it should be a lot of fun. All right, now without further ado, let's move on to the moment everyone has been waiting for, which is who's the winner? So in third place, we've got Leaf in the Wind. Excellent job. In second place, we've got Cosmic Chances. And in first place, our grand prize winner is Maelstrom 127. Congratulations to all of our winners. Congratulations to everyone who played. If you put your correct email address into Kahoot, we will be contacting you within the next few days in order to let you know or to be able to send you your prize. And if you want to play again in the future, our next game will be in February on, I'm just checking the date here, on February 8th, which is another Tuesday, and again at 7 p.m. So thank you all for playing. Congrats once again to our winners. I hope you had fun and you learned something, and we'll see you next time.